Good morning, everybody. Welcome to the webinar series being conducted by Internet at INCOIS. Today, the Indian Argo program, the applications of the Argo data and the data availability. Many might be interested in the data and things like that, and then summarize at the end. Coming to the design of the Argo program, the basic idea for this particular program has come up with the idea that it should be combined with altimetry data and use it for climate related studies. So in line with this, it was proposed to deploy each float in a 3x3 box and take profile up to 2 kilometers depth. Many experiments were done by various centers, and the design has been based on this output of these particular experiments done at these centers, and decided based on the error estimate that was obtained using available XPT data. So right here the picture shows what are all the available XPT lines, and along those lines the error estimates, like for example, if you deploy the floats across this particular region, what is the error, and if you cover the entire region, what is the error, and things like that. So based on that type of studies, the Argo program was designed so that it can be deployed one in 3x3 box. Bus has been chosen as the level of no motion, assuming that the currents will be minimal there, and also this can be used for calculating the dynamic height based on this temperature and salinity profiles, and also the geostrophic currents. So the right side equation shows how this Argo data can be used as a complementary for the altimetry data, very well computed. So this is the basic idea with which the Argo program has been designed. And coming to the novel nature of the Argo, as I told in the beginning, Argo program is unique for several reasons. First thing is the distribution of data is throughout the oceans is uniform, rather than dependent on the Argo program. People used to go on a specific scientific cruises or along ships of opportunity and then get the data. That's how we see it continues to be so. But the thing is, then it is not uniform. Most of the ocean remains unmapped. So that's the reason why this particular program is unique, that it covers those regions. And there is a lack of seasonal bias since the floats operates year round. So earlier, as I told, when somebody goes on a specific scientific cruises, obviously they cannot plan to cover every season, every month, and every area, season, irrespective of the month, irrespective of extreme climates, so that we have a bias removed when you try to use this particular data for any climatic studies. And the efficient data management network, that's one of the best data management network. It is formed including all the members from all the countries. They should be populated within 24 hours, scientifically quality content, and also once in 6 months to 1 year in a mode called delayed mode for another set of scientific applications. So the best data management network is there, making sure this data is available to all the users free of cost within 24 hours. And another great thing about this particular program is it's a multinational collaboration, which is employing deployment methods by collaborating and also monitoring and analyzing the float data, and then trying to come up with some very good scientific outputs based on this particular data. So just to summarize the novelty of the Argo program, this table shows the availability of data based on ships of opportunity, and then XPTs, and then Argo program. So if you see the ships of opportunity, the top column, it is in 8 years the World Ocean Circulation Experiment has collected data, and it is nearly around, but it took almost 8 years, and the depth up to which the data was collected is something like 1,000 meters. And the XPT from the routine shipping lines, we generally get around 25,000 per year, but the 50 meters. If you can see the maps, both the maps have got limitations. That is, there are many gaps in between. Suppose if we use this particular data to make any climatology or things like that, obviously it will be coming up with huge errors where there is no data, and also there will be a lot of biases. So below picture shows the Argo program, where it is conceived to design 1 in 3x3. If you see, like, very well mapped, there are no regions where there is no data, and then Argo program covers the entire globe, thereby eliminating the seasonal biases and things like that. So that's the best thing about Argo program. And coming to the collaboration and data sharing, as I told in the beginning, it's a multinational program. So there are almost like 23 different countries contributing almost from a single float to more than 50%. Like US is the biggest contributor. Almost 50% of the global array is being contributed by US. And other countries, for example, India has contributed almost like 493 floats, so roughly 500 floats to this particular program. Coming to the management of the Argo, there are two sets of teams. One is called the Argo steering team, the other is called data management team. And the science team, the science component of the Argo program is managed by the Argo steering team, and the data management component is managed by the ADMT, that is Argo data management team. And also the monitoring of this particular deployment and then things like that are all done by Argo information centers at JECOMS, which is there in Toulouse, France. Okay, so this is the biggest three groups that manage the entire program. There are certain restrictions with this particular program, that is float should not be deployed in the EEZ, and any float entering into EEZ to be notified to the respective countries. This is a routine practice which each deploying country does. And real-time quality control data is to be disseminated within 24 hours to the user, and also through GTS also it should be delivered. And there is another set of QC called delayed mode quality control, which is done once the float achieves something like 6 months or even 1 year, and people will cross-check to see if there is any degradation in the quality of the sensors and things like that, and then they start to correct those particular data and then push the data back to the global data centers. This is called scientifically quality control, delayed mode quality control data. So this is the collaboration and also the data sharing part of the Argo program. This is the latest picture as of yesterday. You can see as proposed by the program, there's a pretty good coverage. There are almost like 3,908 floats that are actively giving data as of yesterday. This array includes not only the core Argo, but also the BGC Argo program, which have sensors other than the temperature salinity like chlorophyll, dissolved oxygen, backscattering, turbidity, and then many other parameters. So this is the best thing about the Argo program. So now that we have some idea, the background about the Argo program, let us get more details into the Indian Argo program. So the program, it all started with deployment of one float obtained from Canada. The METS has given one float to India or INCOIS, and then they trained us in how to handle this particular float and how to deploy and things like that. The then program investigator, PI of this particular Indian Argo program, Dr. Ravichandran, has taken this particular float and deployed in Arabian Sea on 22nd December 2001. And then this float has given valuable insights about deployment and also the importance about ballasting and things like that. So the picture below shows all bigwigs of the Argo program about Freeland and Dr. Radhakrishnan, the first director of INCOIS, Dr. Ravichandran, Harsh Gupta, secretary of MOES, and Howard Freeland. So this was kickstart in 2001, where the float was given to INCOIS, and then subsequent deployment happened, and then the data was collected and processed. So this is the data that the float has given, and you can see there are lots of gaps in between. This highlighted the importance of the ballasting, because the float was intended to be deployed somewhere in the Canadian waters, but this was deployed in Arabian Sea. So the water structure is completely different to that of that. So the float has not reported data during specified periods when it is not having the conducive environment to surface. So according the float used to skip those profiles and then skip and give only data whenever it is convenient. The surface waters or the waters are conducive for it to come up to the surface and give the data. So we call it as the float has taken summer vacations, because it never used to give the data during the summer. And the first set of results from this particular float has been published in Current Science in the name of results from the first Argo float deployed by India, and wherein all these issues with this particular float, ballasting, data processing, QC, everything has been highlighted. So after gaining the experience from handling this particular float, then India went on to procure their first set of floats, and these floats were deployed during a cruise from Chennai to Mauritius during the period of November to December 2002. And this 10 set of floats included both Apex from manufacturer from US and also the manufacturer from Metz that time, and now it is in France. So these 10 set of floats have been deployed, and India subsequently went on to procure and deploy as many as 493 floats as of today, and this is the contribution from India to the International Argo program. So this picture gives a idea how exactly the float works. This is a cross section of the float, how it looks like, and also how the float functions. So once deployed, the float sinks to a predefined depth, which we call profiling depth or a parking depth, and sometimes the profiling parking depths are distant for distant floats, but sometimes it is same. So the float stays there at that particular parking depth for almost 10 days, and when the time approaches for it to measure, it just sinks to the profiling depth and then start going up. While it is surfacing, it keeps on measuring the temperature and salinity at a predefined depths and stores the data internally, and once it reaches the surface, communicates back to the satellite, which is received at the ground station. So this is how the Argo float works in a nutshell. And you can see drifting depths for most of our floats are set as 1000 meters, and profiling depth is set as 2000 meters, and also 10-day cycle have been set for most of the profiles floats in the Arabian Sea, and 5 days cycles have been set for most of the floats in the Bay of Bengal. So just to tell how it works, what happens, there is something like a hydraulic liquid inside the float, which is pushed into the bladder. When the bladder expands, the float becomes lighter, and then it starts to surface. And once on the surface, the entire oil has been sucked back from the bladder, and then the float becomes heavier, and then it starts sinking into the predefined drifting depths. This is how the entire float works. So right side is a cross section. You can see the entire mechanism, how it works. There is a reservoir in which the oil is there, from which it is pumped into the bladder and sucked from the bladder. This is how the buoyancy has been adjusted such that either float sinks or the float surface. So this is how simply it is managed, and then the data is measured at the predefined depths. These are some of the pictures during deployment by our colleagues at INCOIS. You can see different types of floats have been deployed at different locations and different cruises. So this is a core Argo CTD float, and this is the float with from the NKE France. The yellow ones are all Apex from the US, and this is the BioArgo float, which has got additional sensors of dissolved oxygen, chlorophyll, backscattering, things like that. And then this is also Apex float with Iridium communications, and this is a plain antenna is the one with Argo's communication. The one on the top like this with the circular thing is with Iridium communications. So we have got all types of floats with different communication channels and things like that, which I'm going to cover in the future slides. So how exactly the float gets its position fixed? The float has got no GPS. This I'm talking about the Argo's communication floats. They got no GPS fixed on the things. As and when they're deployed, they're free to drift. But while on the surface, there are Argo's constellation of satellites traveling, measuring the globe. So the float communicates to this particular satellites by sending the message packets, and based on the receiving packets received by these floats from the floats, the satellite fixes the position. We can see the right side based on the Doppler shift, and we get an error ellipse for each of this float position fixed by this Argo's constellation of satellites. So the position information along with the data is dumped by this satellite to the ground stations, and which we use for processing and decoding the temperature profiles and salinity profiles from this particular data. So coming to the sensors, we have got different types of sensors on our floats. The initial set of floats has got two FSA sensors and 393 Seabird electronics, which includes both SB41 and SB41 CP for continuous profiler. SB41 CP is mainly on Iridium communication floats, and then SB41 is mainly from the Argos communication type of floats. And we also have 16 dissolved oxygen, 2 from Andera sensors, and 14 from Seabird electronics again, deployed in the early years 2006 to 2008. And then we also have 15 floats with near surface temperature mission, giving very high resolution data of 5 meters to the surface, which can be used very well for studies related to validation of sea surface temperatures from satellites, and also defining bulk temperatures, skin temperatures, things like that. And we also have deployed 67 BioArgo floats, which includes dissolved oxygen, fluorescence, and then backscattering. So you can see different types of sensors, how they look like, which are fitted onto the Argo floats. And coming to the accuracies, temperature sensor has got accuracy of 0.002, and then salinity has got 0.005 PSU, and then pressure has 2.4 dBars, and additional oxygen, chlorophyll, rain, nitrate, light attenuations. All these are different types of sensors that are fitted onto these particular floats. And this is the deployed locations where the INCOIS or India has deployed, and the red one are all those with Iridium communications, and the yellow one are all those with Argos communication channels. You can see mainly the Indian contribution is covering the Northern Indian Ocean, and whenever we had some opportunity of our sister concern NCPOR ship going to Antarctica, we used those opportunities and deployed floats in the Southern Ocean also. So the right side you can see type of sensors and type of satellites. With CTD alone 395, with near surface temperature mission 15, with dissolved oxygen alone with 16, and then BioArgo floats, which we call CTD plus CHLA, dissolved oxygen, fluorescence, and black scattering, things like that. There is 67 floats have been contributed. And coming to the type of satellites, Argos communication is the biggest contribution from our side, which is 386, and then Iridium communications, both which includes Rudix and then short burst data format. Around 107 floats have been contributed from India. So coming to the processing chain, we all know now that INCOIS deploys these floats, we get the data, raw data from these particular floats, and we are the agency supposed to process this, do the quality control, and then push them back to the global data centers. So the processing chain is like the one which is there in the dotted box is mainly done by India, and the one below by the other floats, which we also tackle as a Argo regional center meant for handling those float data also. So what we get is like we get data in various formats. We call them as TX formats, DX formats, and then short burst data, message formats from Iridium floats and things like that. So there's different formats we get data from these particular floats. We get the surface drift information based on this position from fixed by the satellites, which we use for creating the trajectory information, and we immediately do a cyclic redundancy check for trying to check if there is any corruption with the packets, and then we get once the CRC is done, we get the raw data sets from 1 to 12 or 1 to 16 depending upon the number of records the float gives, and then from this float information message packet 1, we get the technical information which can be used for monitoring the health of the floats, and the rest of the packets are all used to get the profile information like temperature, salinity, and things like that. Then once this is decoded, we perform a real-time quality control, which has got 19 QC checks as prescribed by the data management team. And once this is done and the quality flag is assigned, we push the data into the global data centers, and also parallelly we push the data into our INCOIS website. This is only pertinent to the Indian floats, but we are also supposed to cater to all the floats being an Argo regional center. And then that's how we get from the global data center Coriolis, which is there in France. The data is downloaded in the netcd format and convert to ASCII, and then we also do some sort of visual quality control checks, generate the pressure, temperature, salinity, and then other parameters data, and then also push it back to our INCOIS databases. So this is in a nutshell the entire processing chain that we follow at INCOIS. And coming to the various formats which I told, TIP and TX formats for Argos communications, either we get 45 records or the 75 records from these floats. Message and log files for the Iridium communication, we get nearly 1000 records, which is a very high resolution. And then short burst data, this is mainly from either Iridium or NKE floats that are from the France. And here also we get around 1000 packets. and we can also set it to any for example, some of the floats we set to around 145 records. So it is how we program and then start deploying them. And coming to the quality control of the data, as I told some time back, two streams of QC are prescribed by the Argo data management team. One is in the real time, to be done immediately after decoding, and flag data to be uploaded onto the GDAC before 24 hours. So the 24 hours has to be maintained without any delays. And then delayed mode quality control to be done no less than 6 months, because we have to wait for a specified period to check whether there is any degradation in the sensor. So that we have to wait for 6 months, and mainly checking for the sensor degradations. So these are two streams that we also follow at Incois. So this is the flow which shows how the Argo real-time data QC is done. So after the conversion, we check for the validity of the WMV IDs, and then also check for the date and time, because Argo program has started sometime in 1999. So we try to check whether data received from this float is beyond 1999 or not. So once that is done, we also check for the position. The position is supposed to be in ocean, because these are all the floats that are giving the data sets of the ocean. So once the position is valid, then we test for the records, temperature, salinity, pressure. There are 15 sets of records that we pass through, and based on the outcome of the records, we either flag them from 0 to 4. 0 meaning no QC done, 1 is good data, 2 is probably good data, 3 is potentially correctable bad data, and 4 is bad data. So this is how we set the flags to this particular data sets, and then output file is created, and this is completely pushed to our web and also to the global data centers. So these are those 15 plus those 3 initial position tests and WMD tests and things like that. So these are the tests that are prescribed by the ADMT, which each of the profile data is passed through. And apart from this, we also do a lot of additional quality control so that the data from this particular floats is really of scientific quality. So what we do at Incois is like we check them for visual quality control. Means experts are there, because we have been dealing with these particular profiles for many number of years. So we know the nature of our Arabian Sea, Bay of Bengal. So based on the visual quality control, we try to test certain flags as good, bad again. And quality control based on objective analysis. So what we do is we grid them and try to see if any bullseyes are there, so that those set of data sets are also again quality flagged and then assigned a correct quality based on that. And we use cluster analysis. This is a machine learning approach, so that the data can be quality controlled. Bulk treatment can be done. And then we also do latitude longitudinal patterns, which we call alpha convex cells, and then also delayed mode quality control. So these are all those processes about quality control that we do at Incois. And this is the 3-way. We have combined some of this, which we call automatic quality control. 19 sets of flags are there. And then we immediately pass those output to an objective analysis. We can see sometimes still there are certain flags, floats, profiles, which are still creating problems, which we call as bullseye. So these type of erroneous profiles are visually quality controlled to check whether they are really good or bad. So all these methods are peer reviewed and then accepted for publications in various journals, and accordingly those methods are implemented in Incois for assigning the quality flags. So coming to the delayed mode quality control, I will deal little more, because it requires little understanding why exactly we do this. Why we do DMQC? Once an Argo float is deployed in ocean, it is very difficult to calibrate. Say for example, if you have a glider, some of you might be knowing about gliders. Gliders are something where you can operate, when after some time we can recover them and then check for the sensor degradations, and you can send it for calibrations. But unlike gliders, Argo floats are not, there is no chance for recovering them unless until we do extensive operations and then get those floats. So since we cannot get them back, we cannot calibrate them. That's the reason why we need to do DMQC. So as I told in the beginning, there is a preset accuracies for this particular floats, and whether we are able to maintain them or not is supposed to be seen based on the data only, because the floats cannot be retrieved. So once the float is like over a year or something, obviously it has some sort of biofouling happening on the sensors, and this can cause some sort of degradation in the sensor quality. So for which we need to check and then do this delayed mode quality control. Generally, the pressure and temperature will not have any issues even after preset like 3 to 4 years, but the salinity has problems, which I show why it just happens, and salinity need to be quality controlled using some high quality CTDs. Hence, the DMQC is performed. So what we do is like compare the available CTD background data with this data obtained from the float, and in this particular process we try to check for drifts in the salinity and TBTO problems which cause some sort of freshening on the initial profiles of the salinity. Sometimes there can be hooks in the salinity profiles, surface pressure offset problems, thermal lag problems, truncated negative drifting pressure TNPD. So all these are checked in DMQC and the quality flags are revisited again. So this is one example where the salinity drift is happening. So you can see the bottom green and red lines are the best available climatologies, and on the top we have overlaid the Argo salinity data from the Argo float. So you can see initially the float is performing very well, and suddenly it started to drift. So this we call salinity drift. It is observed in this particular case for somewhere in the 44th cycle. So in comparison to the climatology, it is deviating. So this sensor has some degradation. And TBTO issues, if you can see, the normal diameter of a clean cell is something like 4 mm. If a small thin filament can happen due to any reason, then the diameter is reducing by almost like 0.002 mm. Even such small film on the cell can cause a error of 0.035 PSU. You can see such sensitivity of this particular sensor. So obviously this can result in the sensor degradations also. So sometimes when there is a TBT or some sort of painting is coated on the cell, which can cause this initial profiles to be freshening. Over a period the paint get washed off, and then the cell starts to behave quite normally after that time. So this can be checked only using a visual quality control check, so which we perform, and then all these initial profiles are set to bad. So also I talked about hooks. We can see small hook-like structures at the bottom of the sensors. So this we call them as salinity hooks, and this need to be corrected, which we done in DMQC process. And the thermal lag creates an artificial spikes at the bottom of the mixer layer, and this you can see the spikes in the salinity sensors. This also need to be cross-checked visually, and then the flag has to be assigned accordingly. And pressure sensor offset, you can see like there is some issues with the sensors, and then there is an offset. So this need to be corrected for the pressure sensors, and then TNPD issues also. Sometimes there can be a negative pressure sensor offset, but it is truncated to 0. That's why we will never know how much that offset is there. So the correction cannot be done. This we call as TNPD issues, and then this also need to be corrected or the flagged accordingly. So once this entire set of QC processing is done at the inquires, what we do is like we generate a set of profiles called the profile files, trajectory files, technical files, and then metadata files, and all these files are uploaded onto the GDAC. There are two GDACs, one is in US and the other is in France. Coriolis is the one at France, and US Godet is the one at the US. So these are the two global data centers to which all the data assembly centers like Incois or India will push their data into. So you can see how the monitoring, there are two different sets of color codes given for real time and then delayed mode. So as and when the delayed mode is processed and then pushed, the amount of delayed mode data available keeps on increasing. So it is said that like when there is a delayed mode data, the preference should be given to the adjusted fields compared to the raw fields, and people are supposed to be using the adjusted fields than raw, unless until somebody wants to revisit the entire QC all by themselves. So this set of monitoring is done at both the GDACs, and people can start downloading the data of their choice. And as I told, the additional quality control that we do, we use cluster-based techniques. What we do is the best available climatologies are all used to build clusters based on the similarity of the properties of temperature and salinity, and the new data is introduced into this, and if it's supposed to belong to the particular cluster, the nearby properties also has to match to that of that. If not, then the quality is set to bad. So that's how the machine learning techniques and approaches are being used to perform the quality control. And this is also, these are all inbuilt techniques along with graphical user interfaces, so that the operators or the experts can use them and then perform quality control. This is how we set the quality flags, and the scientifically quality control data is made available to the user. And what is the purpose of this particular data? People can be using the individual data sets, but sometimes people want some sorts of value added products generated out of this particular data. There are almost like 3 million profiles right now, and imagine if you can come up with some good gridded products out of this. So that is one thing that we also do as a Argo Regional Center of Indian Ocean. So using all these quality control temperature salinity profiles, we generate gridded products based on objective analysis and variation analysis. And the spatial extent that we generate is 30 degrees to 120 degrees east and 30 south to 30 north. So this is the area where we are concentrating. And the temporal extent of this particular product is something like 10 days and also the monthly. And coming to the data delivery, we deliver this particular data through our live access servers. This is the URL you can note down and then just cross check for our data sets there. We also send this data offline through CDs. We have an Argo Data Viewer product that we have generated, mainly targeting students who may not be able to download bulk amount of data sets. So this Argo Data Viewer CD has got all the GIS facilities like on the website, and people can just get their entire data in a single go and then keep it for their use, perform same user interface query building and then filtering and then downloading, things like that. And we also sometimes create this data and then put it into FTP, secured FTP for the Indian Navy to download. So these are some of the snapshots of the value-added products that we have generated. These are the temperatures at various depths, salinity, and then geostrophic currents, mixed layer depth of 20 degrees isotherm, heat content up to 300 meters, and then dynamic height and things like that. So these are all products generated and reports generated and then also available for people to use. And there is one group in Coriolis, France, who have come up with the currents based on this Argo data. The parking depths and the surface, whatever is, all those informations have been used, and then the currents are derived at 1000 meters. This paper is published in JOT. Michel Olliott is the main author for this particular paper. So this current data is also available for people to use for the scientific analysis. You can go to the Coriolis website and download the information for this particular climatology and also the corresponding paper. And the other sources is like UCSD is one best source where you can get this particular data. There are many functionalities, like for example, they give the data files and there's some many software tools for visualizing this particular data, and also they combine all the data products from different centers and then make them available here. And they also have visualizations and web-based applications, and they also are collecting the model outputs and real analysis products that are utilizing the Argo data. So this is one good source where you all can download, visualize, and then get more information on the not just Indian Argo program but also the international Argo program. And coming to some of the websites which you can access and to get the data and data products, as I told, the Argo UCSD is one thing, and Global Argo Data Repository, that's another source maintained by NOAA. And regarding the biogeochemical float data, there is one website dedicated to biogeochemical Argo, and you can go there and get, this is the web page showing the biogeochemical Argo information. And then NCAR has come up with some climate data guide based on this Argo data. And also there is one Argo data management website where you can get the stats for different DACs. You can also get information about DMQCs. You can also get information about tools and many other things like that. So these are one of the not an exhaustive list, but the main sources where you can get to access the data and data products. And this is the page in the Argo data management website. You can see different institutes coming up with their own different types of data and grid fields and the descriptions here. What are the different sources they are going to use, and the resolutions and the temporal coverage and temporal resolutions and things like that. So you can directly go here, get the data in the NetCDA format and then other formats of your choice, and then start working for your scientific analysis. As I told, the offline products that we are preparing and then making it available to the users. So this is the Argo DVD product which I've talked about. Users can put a request to us, and then you can get an FTP access for getting the image of this particular software. You can directly install one time in your system and start accessing. So this need not have an internet access and things like that. Once you install, it can be used with all those GUI facilities which is there on our website. and also through live access server we distribute our gridded products, and also through our ERD app also all this data and data products are being made available from the Indian Argo program. And coming to this much, we talked about the data. Now we should also know a little more about what are the different applications this particular data has been used for. One thing good thing about Argo data is like it's an open nature. Earlier people used to go on a specific cruises, and sharing the data from these particular cruises is really difficult, because they would like to use this particular data for the intended purpose for which they have undergone this cruise, and then publish papers and then further collaborate with people and things like that. So data coming out to the user is really difficult, but that entire thing has been changed with this Argo program. It is open for access to all people irrespective of the country, irrespective of region and all that, and also available within 24 hours, and also scientifically quality controlled and available within 6 months to 1 year. And people have been using, once this data is out, they have been using for many purposes. Some of the things I listed here, the Argo data was extensively put to use for understanding the intra-annual to intra-season oscillation studies in the Indian Ocean. Ravichandran et al. Has come up with many publications, and mixed layer and barrier layer process, Uday Bhaskar, Girish et al. Has published many papers. Circulations in combination with sea level data, Sudhir Joseph et al. Has published some papers. And upwelling downwelling processes, Chiranjeevi et al. Has used this particular data. And also for climate change studies, CHLA trends, Satyaprakash, Prince Prakash, Satyaprakash, and then all has published many papers on this. And also the data has been assimilated into the models. Inquise runs host of models like MOM, Modular Ocean Model, ROMS, HICOM, and things like that, where this data is being assimilated into. So the assimilated data products are also available as a product called RAIN in Inquise, so that also people can use. And Ravichandran et al. Has published papers on this assimilation in ocean modeling journals. And these are also used for validation of satellite data. This near surface temperature and near surface salinity data has been extensively used for validating the sea surface temperature from satellites, and also sea surface salinity from satellites. So Rahman et al., Uday Bhaskar, Satyaprakash all has used this particular data for validation of the satellite data. And also these have been used for generation of analysis products and many more, and building new climatologies and coming up with many atlases. Abhishek has come up with an improved climatology, including the data in the EEZ from the Argo float, and this is published in Journal of Earth System Sciences. And many atlases have been built. For example, Uday Bhaskar has published atlases which are mainly for the application and used by the Indian Navy. And the recent addition is the BGC data. The focus is completely shifting onto the BGC, because temperature and salinity is okay, but many people are now working on biogeochemical studies in the Indian Ocean, where this data has been put to use. In the Indian Ocean, the biggest contributor is India, with 67 floats, BGC floats deployed over a period of almost 8 years. And there are many studies now being published using this particular BGC data. For example, studying the role of eddies in ocean minimum zone, and then the variability of ocean minimum zone in oxygen minimum zone in Arabian Sea and Bay of Bengal, and the chlorophyll variability during cyclones, and the preferential zones of tuna fish. And then there are many papers. These are all available on the Argo data management websites, and also there is one bibliography being maintained on the UCST website right from 1999 to the latest years. You can see almost 1500 papers have been published since the Argo program has began by various countries. And India alone, as many as 100 plus papers are published in peer-reviewed journals by the Indian scientific community. So this slide shows the journey, the past, the present, and the future of the Indian Argo program. In 2002, we started with the basic CTD type floats, and deployed with a modest 10 floats, and then we went on to acquire floats with dissolved oxygen and the near surface temperature sensors, and that deployment was done between 2006 to 2008. And BioArgo floats and with chlorophyll backscattering dissolved oxygen deployment started sometime in 2013, and as of today we have contributed 67 floats. And 13-14 is the year where our first set of floats have been BGC floats have been deployed. And now We are also in pipeline to deploy floats with nitrates, deploy deep Argo floats, that is because these floats can go only up to 2000 meters, but to close the budget, people need to depth for even deeper layers. So that's why we are planning to procure and deploy floats that goes up to 4 kilometers or 6 kilometers, and also with additional sensors like nitrate, pH, and things like that. So this can be extensively used by the biogeochemical modelers for their model validation, assimilation, things like that. So that's the past, and what is currently going on in the present, and the future plans that the INCOIS is planning to. So this picture below shows the beginning, where 2002, when we first deployed our set of floats, to the current status. You can see the entire Indian Ocean has been filled with the data that India and other countries has contributed to during the course of almost 2 decades. So that's a successful journey from almost a data void region. Indian Ocean is mainly called as data void region for long, but with this particular program, I think we can confidently say that it's no more a data void region, and this particular data can be extensively used for unraveling all those things that Indian Ocean is kept pending, and then this data can be extensively used for unraveling them and then publishing pretty good results, so that Indian Ocean can be much better explored. So in summary, the Argo program has become an indispensable observation system, pumping in almost like 1 lakh profiles per year for use by oceanographers, which was not possible even in the wildest of the dreams in the earlier years, where people used to go on cruises, specifically collecting few tens of profiles. And it sustained initial hiccups. There are a lot of problems in the beginning with battery problems, premature depths by the floats, and then also it had a huge problem with the pressure sensor offsets due to micro leakages. And now it has become more and more robust. The life of each float has now been more than 4 years, and some floats have gone even up to 7 years. So that's how well the Argo program is now being managed. And also efforts of all the deploying nations and the ADMT should be given due credits for sustaining this particular program, so that like all the users can get data, scientifically quality control data for their applications. Thank you. I'm open for any questions now. Questions accepted. I'm just checking the questions. I'll be back to you in a couple of. Just checking the questions. I'll be back to you in a couple of. Just checking. Yeah, there are many questions by Chandrasekhar Prabhakar. I'll be trying to answer some of them. Why can't India produce these floats as part of Make in India program? That's a pretty good question. We are collaborating with our sister concern NIOT, which is there in Chennai, and they have deployed 4 floats, and we have tested the data from that, and it is proven to be pretty good. So right now we are trying to partner with some industry so that they can come up with some bulk productions, and once it is proven, we are going to procure from them and then deploy in future the floats from India itself. So just to say, it's an ongoing effort. Which machine learning algorithms are being used for quality control? Yeah, there are many things we are using. We are using cluster based, as I told in the beginning, and also we are also using artificial neural networks to check the sensor quality and then trying to fix based on the testing and training that we have done from the World Ocean Atlas, World Ocean Climatology, and those results are also being right now sent to a journal for publication. So it is under review. And cluster based techniques also, what we did is k-mean cluster, and then nearest neighbor is the one which we use to build these clusters and also use these clusters for the quality control of this particular data. And visual quality control is it by which watching manually or by advanced program. See, visual quality control, we use experts, because over a period the expertise of the scientists and inquiries will be used, because we know the nature of profiles, how they look like in Bay of Bengal, Arabian Sea and things like that. So based on that profile structure, the expert will be able to tell whether the quality is good or bad. So that's why we prefer a manual. But during my presentation you would have seen, we are not going to entire millions of profiles to the expert. We try to filter as much as possible and try to give minimal things that need visual inspection. So we already are doing an automatic quality control checks and object analysis based checks and all that. We filter out and the minimum profiles are given so that these are the one that needs attention. So that's why we definitely rely on the expert to check and then set the quality flag accordingly. Can you share the CD media to download from inquiries? Yes, that is there on our website itself. If you can write back to me, uday@inquiries.gov.in, I can share the link with you so that entire image of the particular CD can be downloaded by you. If not, you can send across the CD, but since the data is now almost 3 million profiles are there, it is not fitting into the CD. It is growing beyond the CD capacity. So that's why we started putting in our FTP. The entire software image has been put in our FTP for people to download. So that can be downloaded from our website itself. Link, you can write to me or you can just check on our website itself, it is available. In case you are not able to get it, please write back to me, uday@inquiries.gov.in. I'll be ready to help you. What are the future plans? I already covered. I told we are planning for deep ocean Argo, because now the modelers wants deeper data to close the budgets of their models and all that. So that's the reason why we are planning to procure deep Argo, which goes to 4 kilometers or 6 kilometers depending upon the design, and these are going to be deployed in future. So we'll be getting more data and deeper data from these particular floats along with the core Argo that is up to 2 kilometers. Are these floats contributing to the ocean waste, marine pollution? Not exactly, because these floats have got something called end of life mechanism built into their system. So they know when the battery are going to get exhaust, they stay on the surface and get drifted onto the coast, and then we have sometimes procured these particular floats and then brought them back to our labs and then kept them. These are not reusable anyway, but they are not adding much to the pollution of the ocean. I hope I answered all those questions. If any more questions are there, you can just keep typing in so that I can just answer. If not, you can write back to me to get any further queries answered.